This call is now being recorded. Good morning once again to all of you.
Good morning, ma'am.
Let's begin with light. It's better that we will interact more because light is a very general topic and you all, or rather, we all know about it, isn't it? Girls?
Yes, ma'am.
Yes?
Yes, ma'am.
So you can talk a lot about it. So let's interact in today's session. Okay, beta?
Okay, ma'am.
So begin. What is light?
Ma'am,
Can
can
I?
I read?
Yes, just give your name and say can I read, so I know whom to ask.
Almas.
Misbah.
Almas, okay, okay. Almas, right now you take up Misbah, the next one, okay?
What is light? Light is electromagnetic radiation with a certain portion of electromagnetic
Spectra.
spectrum. Spectrum. The word usually refers to visible light, which is visible to human eye and is responsible for the sense of sight.
You understand now? Actually, what is light? It is a electromagnetic radiation. It is a electromagnetic. Purposely, I've used this word. You're not supposed to. It's a type of radiation. That's all. But what type of radiation? Electromagnetic radiation. It's clear? Just hear it. I don't want to go in detailing right now because when you go in 8th standard, then I will do detailing. But just to make you understand that these are the terminologies that you will come across. Okay? So when you go to 8th standard, now things will be very easy. You already know about electromagnetic radiation. You understand? That means
Yes.
what sort of effect it has? It has got electricity as well as magnetism. So that's what it's called as electromagnetic radiation. This one you understood better?
Yes, ma'am.
So this refers to visible light. Whatever you can see, just look around yourself. Things are visible. Why? Because our eyes can perceive the light from the sun. And when it gets reflected from certain, we can see that object. Until and unless the reflection takes place, we will not be able to observe any objects. Do you understand? So
Yes.
what is required? Reflection is required. If there is no reflection, we are blind. What did I say, beta? If there is no reflection, then we are blind. Is it clear?
Yes.
Yes, ma'am.
Yes. Okay. So this gives us the sense of sight. So which is having the perception of the sight, perception of the light? It is our human eye. You got it now? So we see things from where? Through where? From our eyes. You understand?
Yes.
So eye is responsible for the sense of sight. You agree, beta? So from where we are getting? From the sun. So sun is the source of light. Any problem? This is the natural source, beta. Artificial sources we know. The tube lamps, the LEDs, yes, the bulb, all these are artificial source of light. But what is the natural source of light? It is sun.
Sun.
Okay, fine. Yes, beta.
I read. Ma'am.
Yeah, Misbah.
Yes, ma'am. Light. Light is a form of energy which is emitted by a luminous body when incident on the eye causes the sensation of light.
Fine. It's a type of energy. You agree, beta? Light is a type of energy, don't you think so? Do you follow me?
Yes.
Yes, ma'am.
Yes. So from where it is coming? From a shining body. What is luminous body, beta? Shining body. Sun is shining, bulb is shining, tube lamp is shining. Yes or no? LED is shining. So luminous body, which can illuminate others, is called as luminous body. And when it falls on the eye, what is the meaning of incident? It is a ray. Rays are falling on our eyes and it gives the sensation of light to be perceived by our eye, and that causes us to see. Okay?
Married.
Now, beta, what's your name? What's your name, beta?
Sileja Mariam.
Okay, Shilethia Mariam. Fine. Welcome, beta. You
Light.
hardly read, I think so. It's the first time you are asking? You're generally not there. Mariam,
Yes.
welcome, beta. Thanks for being present today. Okay, start.
Light is form of an
Characteristics. Characteristics.
characteristics of light rays. Light
Okay.
is form of energy which always travel with maximum velocity. Light travel in straight. When light rays fall on smooth reflecting surface, angle of incidence is equal to angle of reflection. Light light undergoes of phenomenon
So,
of
beta, don't read
phenomenon.
wrong. If you do not know, ask me. But don't read it wrongly, okay? Light undergoes the phenomena of reflection.
Light undergoes of phenomenon
Phenomenon.
pheno,
Phenomenon.
phenomenon
Phenomenon.
phenomenon of reflect
Phenomenon of
phen,
reflection.
pheno,
Phenomenon.
phenomena of reflection. Re-
Refraction.
reflection.
Total internal
Reflection
reflection.
total. Internal reflection. Interference.
Hence, dispersion.
Dispersion.
Diffraction.
Diffraction. And,
And polarization.
and
Polarization.
polarization.
Very good. Very well tried. Last.
Light undergoes of
Phenomena
phenomenon
of
of tracking,
scattering.
discovered by C.V. Raman.
Raman. Okay. Who is this person, beta? He was a Nobel
C.V.
Prize winner. C.V. Raman.
C.V.
Okay?
Raman.
Yes, C.V. Raman. So now I will explain to you everything. Now, what are characteristics of light rays? What light rays have got? What are the features of light rays? First, we know that it is a type of energy and it travels very fast. It's got a maximum velocity. It travels very fast. You can see sun is so far away from us. Am I right? Is sun very near to us or very far to us? Or far from us?
Very far to us.
From us, sorry. Very far from us. You all agree. But still, we get so much of heat from it, so much of light from it. How come? Because it is traveling at a very high speed to the earth. You agree? You agree? Hello? Girls, do you agree, beta? That it's traveling at a very high speed?
Yes, ma'am.
Yes? Okay. Also, it travels in a straight line. We will do certain experiments, like you take a pipe and place one candle on top, like this is the pipe. Take a pipe, okay, and place a candle over here. Place a candle over here. Yes, beta? And observe your eyes over here. Your eyes over here. Observe with a straight pipe. You can see the candle. Can you see the candle? You can see the candle. But now what I will do? I will take another pipe, but that pipe is like this. Okay? The pipe is like this. And I am observing from here. This is my eye. And I have kept again a candle. Okay? Will you be able to observe it, beta? Girls, will you be able to observe it?
Yes.
No, ma'am.
You will be able to observe it. Who said yes? Okay. If yes, then give me the reason. If no, then give me the reason. Someone said no and someone said yes. The yes, please give me the reason. And no,
Ma'am, because the pipe is tilted so that the light cannot come on the other side.
exactly. But you had said that you can observe the candle. Just now someone said that yes, the candle can be observed. That's why I asked you. It cannot be observed. Why? Because we have suggested that light travels in a straight line. You understand?
Yes, ma'am.
What we observe? Light travels in straight line. This activity suggests that light travels in straight line. You can do this activity at
Yes.
observe with a straight pipe and try to observe with a bent pipe. With bent pipe, you will not be able to observe, but with a straight pipe, you will observe to see the candle on the other side. Is it clear?
Yes, ma'am.
That shows that light travels in a straight line. Whenever the light is falling on a smooth surface, now this is a light. This is the light falling on a smooth surface. So it is the incident light. It is the incident ray, I. It gets reflected. See that you can see the arrowhead? It's going out. It gets reflected. So what is this arrow called as? R. Okay? So what it becomes? Angle of I and angle of R is equal. So what I will write? Angle I is equal to angle R. This is the first law of reflection. You understand?
Yes, ma'am.
Yes, angle I is equal to angle R. This is what you are going to learn in this chapter. Now we have lots of phenomena of light starting from reflection. Just now I showed you reflection. Then we have refraction. Then we have total internal reflection. Just hear it. You don't have to learn anything about it. We have to learn only reflection and nothing else. Interference, dispersion, diffraction, polarization. All these are the features of light. Can you imagine? Can you imagine? Okay, I just will tell you one thing. The spectrum that you get, the rainbow that you get, that is dispersion. What it is, beta? Hello? The rainbow that you get on the sky, it is due to dispersion of light. Okay? Okay, beta?
Yes, ma'am.
And you can do another activity. Take a glass of water. You put your pencil and observe and let me know. You will see as if the pencil has broken in between. It seems to be bent. It seems to be broken. When two surfaces, two media are meeting, that is one is air and the other is water, that image, that structure that you get when you place a pencil or any straw or anything inside a glass, that is due to refraction. What it is, beta? Refraction. These are all types of phenomena that I'm trying to tell you. You can do this activity at home also. Put a glass, take a glass with water and place a pencil in it and see how does it look, okay? And let me know. Now all these activities, the scattering activities, that light undergoes scattering, it was detected or it was discovered by who? A very renowned scientist, C.V. Raman, who was a Nobel laureate. Any problem, beta?
No,
Any
ma'am.
problem? Okay. See, read beta.
Light is the main
No, light
reason
is the main.
main reason why we can see without light. There would be no sight. It is because our ability to see is due to the interaction between the light. the brain and the eyes.
Fine. Light is the main reason. Why we can see? Due to light only. Can you see in the dark? I told you it has some interaction better. You have to give me an answer. Can we see in the dark?
No, Babu.
No. Fine. We tend to fall. So what is main reason? Light has to be there to see. Light has to be present. Then we say, no, put on the light. We cannot see anything. Don't we say that? Yes, better? So
Yes.
the presence of light makes us see. Without light, there would be no sight. That means we would be blind. Because of our ability to see, why? Because something is happening inside our body. There's interaction. See, the word interaction means there's a combination, there's a coordination between what? The light, that is the source, then the brain, which registers what you saw, and the eyes, which is receiving the light. Do you understand? One is
Yes.
source of light, the other one is your eye, which is receiving the light, and where the message is going better, it is going to the brain, where it is registered that yes, what you saw was right. You understand?
Yes.
All of you better? See, in each and every slide, you are learning something new.
Yes.
Yes? Oh. Any problem regarding this beta? If you have not understood, ask me. I will explain it again.
Okay, ma'am.
Do you want me to explain again?
No, ma'am. No.
Now let's see how this eye looks like. Yes.
Vision responds to the stimulus of light.
So what you see is a response. You received something and it got reflected from your lens, which is in your eye, and you observe whatever you're observing. So that is a stimulus of light. You are responding. What is your response? You saw. Because light went into your eye and the eye has got lens, right? So through lens, the light went inside your eye and the brain registers what you saw. So the response to the stimulus of light, when you see light, what is the response? You observe something, you look something, you look at something, you see something. That seeing something is a stimulus of what? Light. Is it clear? And this is how our eyes look like. And which is the important thing? That is a lens. See this, you can see this? The one which I'm making red better.
Yes.
And to correct this lens, there
Yes.
is an image formed. I will just show you. Where is the image formed beta? You can see this retina. Can you see this retina beta?
Yes.
See. Whatever you see, the image is formed here. Can you see this yellow color?
Yes.
Retina. The one which I have highlighted, you saw beta?
Yes.
Formed. Okay, this yellow colored border. Can you see this yellow colored border?
Yes.
This is where the image is formed. Any problem?
No, ma'am.
This is how eye looks like. Okay, and whatever you see, this message
Brain.
important.
Yes.
That is called as lateral inversion. What it is called, beta?
Lateral inversion.
Inversion. You understood? Your left looks right, your right looks left. That's it. Okay?
Okay, ma'am.
For example, read.
You are the object and what you see in mirror is your image. You are identical to your image as seen in the mirror. In case of a plane mirror, the image formed is erect and same size as the object, but there is one difference is in your left and right. When you move your right hand in the image, it seems as your left hand is moving. This is called lateral inversion, where left appear be right and to be right and right appears to be left.
Understood what I told you just now? Girls, did you understand?
Yes.
You stand in front of the mirror, your image will be erect, straight, of the same size as yours, isn't it? Do you look fat in the mirror? Do you look thin in the mirror? No. Whatever you are, you look in the mirror. Yes or no?
Yes.
Yes. The only difference is that if you raise your right hand, it looks as if your left hand is being raised in the image. Agree?
Yes.
All this of right,
No.
all the girls, any problem?
Mm,
No, ma'am.
This is what, beta? Lateral inversion. What it is called as?
Lateral
Lateral
inversion.
inversion. This is the right hand, isn't it? This is the right hand, and this looks to be left hand. The image. Yes, so beta.
Yes.
One activity I just have showed you, but it will be easy for you to understand now. One activity is showing that light travels along a straight line. Please begin.
Activity. Light angle candle. Fix it on a table. Take a piece of straight pipe or a rubber tube. Look at the candle through the pipe. You can see the candle flame. If the pipe is bent, you cannot see the candle flame. This shows that light travels along a straight line.
Explain, beta. See over here, you're looking at the candle flame. You can see. You can see.
Yes.
When you bend the tube, not, and
Yes.
that's the difference. So what we say, the light travels in a straight line. The one feature that we observed is light always travel in a line. Problem.
No, ma'am.
We're going to talk about important phenomena, that is reflection light. Whatever colors you see, whatever objects you see, wherever you look at, all due to reflection and nothing.
Yes. Reflection. When a wave strikes an object and bounces off.
Bounces.
Bounces.
Bounces. It's light is a wave, you know that. Light is a type of wave. And then extraction object and bounces off. That means it gets reflected. Call it bounces off.
Reflection of light. Reflected light is a light that is bounced back from the surface of an object.
This is a reflecting surface. ray falls on the reflected surface. You can see this arrowhead. This arrowhead, beta.
Yes.
So what is this ray called as? Incident ray. Stay with me.
Incident
Incident ray. It bounces back in the form of which ray, beta?
reflected ray.
All of you understood? All of you understood, beta? Because I'm addressing you, beta. Are you understanding? Seventh
Yes.
standard?
Yes, ma'am.
Now, okay. What I do now, I make normal. I take a normal rather. Line normal. It makes 90 degree. Makes 90 degree to the surface. Agree?
Yes.
So I take a normal in between which make 90 degree to the reflecting surface. You agree, beta? So what is happening now? If I measure this angle and I, if I measure this angle with R, I will find angle I to angle. Understand?
Yes.
First law of reflection. First law of reflection, beta. Angle I is equal to angle R. Is that clear?
Yes.
All of you?
Yes, ma'am.
You have to draw also. Remember that. Yes, start.
The ratio of the amount of light reflected by a surface to the amount of light falling on it is called reflect, reflectance reflectance of the surface and is usually expressed as a percentage.
So the amount reflected. How much amount is reflected? The amount of light is reflected by the surface. How much amount is falling onto the surface called reflectance of the surface. That means the light falling on the surface, light bouncing back by the surface as percentage. Understand?
Yes, ma'am.
This reflectance is expressed as percentage. Extra information I've given you. Please read.
Polished metals will have a higher percentage of reflectance than wood. Smooth glass will reflect more light than rough glass.
That shows that more the shiny the face will have higher percentage of agree. If the surface is rough, that the reflectance will be agree.
Yes.
Yes, all of you. So if I polish it and make it glossy, make it shiny, so reflectance will be high as compared to wood because wood surfaces are generally very rough. So reflectance will be less. Same way, if you take up smooth glass, it will reflect more light as compared to rough glass. Simple. So what is required for the reflection? Smoothness. What is required, beta? Smoothness. The surface has to be smooth for better or for the best reflection. Okay? Yes.
The more perpendicular the angle of the light, the less the reflectance.
For example, we know that this is the surface, shiny surface. If the angle of light is almost perpendicular, because we know that this is the perpendicular. What is perpendicular? 90 degree. If the angle is of incidence is more perpendicular, so obviously reflectance will be less. What will be less, beta? Reflectance will be less. You understand? If it is like this, can you see this over here? If it is like this, then the angle of reflection will be more. You understand?
Yes, ma'am.
You see the parts of the rays of light. Please begin.
Rays of light. Incident ray leaves the object and strikes the mirror.
Okay. You can see this incident ray. See, incident ray. What it is doing? It's striking the mirror. This is the mirror. It is striking the mirror. Yes, and it got reflected. Can you see this? It got reflected. So this is reflected. Any problem?
No, ma'am.
Read.
Reflected ray leaves mirror and strikes your eye.
So this incident ray strikes the mirror, gets reflected. Where it strikes now, it is striking the eye, isn't it? Your eye is receiving. Yes, beta? Hello.
Yes, ma'am.
Yes, understood now? Okay. Next. What happens?
The reflected ray is on the line of sight from the image to your eye.
So understood now? The reflected ray is on a line. See this? This reflected ray is on the line. So object is this one. Where should be the image? This much. So it's both the things are in the line. You got it? So when you proceeded, the reflected ray and the image is in a straight line. Any problem?
No, ma'am.
Yes, read.
Law of reflection. Number one, the incident ray, the reflected ray, and the normal to the reflecting surface lie on the same plane.
So what is the second law of reflection? First law of reflection was angle I is equal to angle R. Yes? Yes, you agree?
Yes,
Angle I
ma'am.
is equal to angle R. Now the second law of reflection is the incident ray, the reflected ray, and the normal lie on the same plane. Can you see over here? See. The incident ray, yes, the reflected ray, and the normal lie on the same plane. Is it clear? They are on the same plane. They're not up, they're not at the bottom, they're not inside, but they're on the same plane. You can draw. Is it clear? This is the second law of reflection. First law is angle I is equal to angle R. Second is the incident ray, the refracted ray, and the normal lie on the same plane. It's clear?
Yes, ma'am.
Again.
Law of reflection. Normal line perpendicular to the mirror surface. Angle of incidence. Angle between incident ray and normal. Angle of reflection. Angle between reflected ray and normal.
Fine. So now in this slide, what have we learned? We are learning about the normal. We are learning about the angle of incidence and angle of reflection. Whereas in other slides, what we learn? The incident ray, the reflected ray, and the normal. Yes or no? Yes, beta? Yes? Girls?
Yes, ma'am.
So here we are going to talk about angles. So first there was normal. See, it is the perpendicular. This one, no? 15 slide. Just remember 15 slide. So it becomes easy for me. So over here, you can see the normal. This is making 90 degree. Can you see this? This is making 90 degree. This is 90 degree. So that is normal, right? What is the angle of incidence? It's theta 1 and this is theta 2. So what I will write? Theta 1 is equal to theta 2. That's one feature of light, that angle of incidence is equal to angle of reflection. So what is the angle of incidence? It is the angle between what, beta? This is the incident ray and the normal. Yes or no? So this is the angle. Yes. What is the angle of reflection? It is the angle between the normal and the reflected ray. Agree?
Yes.
Yes. That's all. We read again laws of reflection. Read better.
Laws of reflection. In incident ray. The light ray falling on any surface is called incident ray. Reflected ray. The light ray that comes back after reflection is called the reflected ray. Normal ray. The line perpendicular to the reflecting surface is called the normal ray. Angle of incident. The angle between the incident ray and the normal ray is called angle of incidence.
Incidence.
Angle of reflection. The angle between the reflected ray and the normal ray is called the angle of reflection.
You understood in this slide what we did? We clubbed everything. We put everything together. First, what we were doing? First, we were talking about incident ray, then we talked about reflected ray, then we talked about normal. Yes? In second slide, we talked about angle of incidence, angle of reflection. Yes? Now, in this slide, we are talking about everything. We're talking about incident ray, we're talking about reflected ray, we talked about normal, then angle of incidence, and angle of reflection. Is it clear,
Yes, ma'am.
all of you? Hello? All of you understood better?
Yes, ma'am.
So again, we see this is incident ray. Can you see this incident ray? This is reflected ray. Yes? And you got this normal. What you got? Normal, which makes 90 degree, right? This becomes angle of incidence, the ray and the normal. Angle of reflection, normal and the reflected ray. You got everything in detail. Now we do some activity for the reflection of light.
Reflection of light. When light falls on a
Time
mirror, direction of light
just check the
changes.
time. Just a moment, just check the time. Is time left or is it over?
Over, ma'am.
Over, no? So we will, because we will have some time for this. We will take some time for this. And the time is already up. We won't be able to continue with it. Okay? Because I need some time to finish this activity. So we continue when? Monday? Hello?
Yes, ma'am.
When do we
Yes, ma'am.
continue? Monday, Peter? Isn't it? Monday we have a lecture, right? So we continue Monday. Please do the revision without fail. It's everything is new. You found things are new to you, isn't it, beta?
Yes.
Yes, so
Yes.
please do the revision accordingly. As soon as you get the upgraded, not upgraded, sorry, uploaded video, go through it seriously. And if any problem, you can WhatsApp me, okay? Or you can call me up.
Okay.
And I think I've got 3 or 4 homeworks, not all. See to it that you submit to Ruby ma'am today itself, beta.
Okay.
Okay, thank you, beta. Thank you. Okay, have a good day and enjoy. Keep smiling. Okay, beta.